In this video, I will show you how to integrate rational fractions. So in this case, because we are dealing with fractions, the formula of integration we're going to use is the logarithm and sum of the inverse trigonometric formula. And as it is shown in the algebra, every rational fractions whose numerator is of lower degree than the denominator can be broken up into so-called partial fractions. And if the numerator is on higher degree than the denominator, we need to apply first division so that we can simplify the rational fractions into partial fractions. That will make us easy to integrate. So in integration of rational fractions, we have three main cases that we need to simplify in three different ways. So first we have the distinct linear factors. The second is repeated linear factors. And the third one is the quadratic linear factors. But in this video, I will focus first in the distinct linear factors. So the distinct linear factors is the simplest case that in which the denominator can be broken up into real linear factors, so none of which is repeated. So in this case, we may always rewrite the given fractions as a sum of fractions whose numerators are constants and those respective denominators are the factors of the original denominator. So if we have function of x in the numerator and we have a distinct linear factors in the denominator of x minus a and x plus b, so we can rewrite this as the sum of a constant over the factors of the denominator, which is x minus a, and the constant that's represent our constant as a and b. Then the next term is the other factors of the denominator, which is x plus b. So therefore, if we can find our constant a and b, in this case we can easily integrate this kind of fractions. So therefore, by finding our a and b, let us multiply the whole function by x minus a times x plus b, which is the denominator. So therefore, from here it will be cancelled out the denominator, so what is remaining is f of x. Then here we can cancel out our x minus a, and what is remaining is a times x plus b. Then in the next term we can cancel out x plus b, and what is remaining is b times the factor of x minus a. So therefore, by letting our x is equal to a, so therefore we can cancel out this function. It would be 0. So therefore, what is remaining is this function. By simplifying, the value of our a here is equal to f of x over x plus b, which is the factor of the denominator of the second term, and we can find this a by letting our x is equal to a, which is we get from this denominator of a. So by this factor x minus a, so therefore our x here will be equal to a. And then in the next, by finding our b, if we have f of x, a times x plus b times x minus a. So therefore, if we're going to find our b, we let our x is equal to negative b, so that in this thing will become 0. So therefore, we can have our equation that by finding our b is equal to f of x over this factor, which is x minus a, which comes from the factors, the denominators of other terms. Then by letting our x is equal to negative b, which is from these factors we can simplify that our x is equal to negative b. So these formulas we can use in the distinct linear factors so that we can easily find our constant a and b. Only we can use this formula in the distinct linear factors. So let's have some examples. So for example, if we're going to integrate a function of 2x plus 11 dx over x squared plus x minus 6. So as you can see here, these rational fractions has distinct linear factors. So we can use to simplify by the way of distinct linear factors. So we have here the two factors of x plus 3 and x minus 2. So therefore our equivalent fractions here is equal to the sum of a over x plus 3 then plus b over x minus 2 dx. So to find our a from our derived formula, our e here is equal to the function of the numerator, which is 2x plus 11 then over, because we are finding our a, our denominator here is the denominator of our other term, which is x minus 2. From these factors we can let our x here, which is equal to negative 3. Then by finding our b, it is equal to the function of the numerator, which is 2x plus 11 then over the denominator of the other term, which is x plus 3. Then from these factors we let our x as 2. So therefore we can easily find our a and our b. So our a here is equal to 2 times negative 3 plus 11 over minus 3 minus 2, which is we have here 5 in the numerator and negative 5 in the denominator, so we have negative 1. And in b we have here 2 times 2 plus 11 over 2 plus 3, so it is simply equal to 15 over 5, which is equal to 3. So therefore by substituting the value of our constant, which is negative 1 and 3, we can easily integrate these fractions. So we have here the integral of a, which is negative 1, so therefore it is negative 1 over x plus 3 dx plus integral of b, which is 3 over x minus 2 dx. So therefore by simplifying we have negative 1 integral of dx over x plus 3 then plus 3 times the integral of dx over x minus 2, and we can easily integrate this simplified function now using the logarithm formula of integration. So in this term we have negative ln of absolute value of x plus 3 plus 3 in this term here ln of the absolute value of the denominator, which is x minus 2, then don't forget to add an arbitrary constant. So that is the final answer. So next example, how about if we're going to integrate a function of x minus 1 dx over x squared plus 5x plus 6. So the first step you should do in integrating rational fractions is to first factor out the denominator. So from this step, you can notice whether the denominator has a distinct linear factors, or the repeated linear factors, or a quadratic factors, and you can apply exactly in simplifying the fraction. So in this thing, as you can see, you can factor out the denominator as x plus 3 times x plus 2. So therefore, in the denominator we have a distinct linear factors. And the equivalent fractions here is equal to a over x plus 3 plus b over x plus 2 dx. Then by finding our a, the value of our a and b, using our derived formula, so our a here is equal to the numerator, which is x minus 1, over the denominator of the other term, which is x plus 2. And we let here our x, because we have here x plus 3, we let here our x as negative 3. So in b, by finding the value of our constant, which represent as our b, it is also equal to the numerator, which is x minus 1, over the denominator of the other term, which is x plus 3. And we're going to let here our x as negative 2, as from these factors. So therefore, we can easily find the value of our constants by letting our x as negative 3. So we have, in the numerator, we have negative 4 over negative 1. So we have positive 4. And in the b term, we have, by letting our x as negative 2, in the numerator we have negative 3, and in the denominator we have positive 1, so we have here negative 3. So therefore, the next step is substitute the constant value in this term, so that we can integrate the function, which is the last step. So therefore, it is equal to, our e here is equal to 4. So we have 4 over x plus 3. Then plus our b is equal to negative 3. We have our integral, we have our dx. Negative 3 over x plus 2. Then dx. So by simplifying, we have 4 integral of x dx over x plus 3. Then plus, or it is minus 3 times the integral of dx over x plus 2. So therefore, we can use the logarithm formula of integration. So we have here 4 times the ln of absolute value of the denominator, which is x plus 3, then minus 3 times the natural logarithm of the denominator, which is x plus 2. Then don't forget to add an arbitrary constant. So that is the final answer. So next example, how about if we're going to integrate dx over x squared plus a times x. So we're gonna follow the steps from our previous examples. So first, we're going to factor out the denominator. So we have here x times x plus a. So therefore, the equivalent partial fraction is equal to, we have also two distinct linear factors in the denominator. So we have here a over x plus b over x plus a and dx. So therefore, also by finding our e here, we also use the formula that we derived. So it is equal to the numerator, which has a function of 1, over the denominator of the other term, which is x plus a. And we let our x here, because as you can see, this is also equal to x plus 0. So therefore, we let here our x as 0. And from b, to find b, we have also 1, which is the function of the numerator over the denominator of the other term, which is x. Then we're gonna let here our x as from these factors negative a. So therefore, by simplifying, we have here a is equal to 1 over a. Then our b here is equal to 1 over negative a. That is our value. So the next step, let's substitute our value. So we have here the integral of a, which is equal to 1 over a over x dx, then plus the integral of b, which is 1 over negative a over x plus a, then dx. So therefore, by integrating, we have 1 over a integral of x dx over x plus, or it is minus because this is negative in the numerator, so we have 1 over a times the integral of dx over x plus a. So therefore, by simplifying, we have here 1 over a ln of x, then minus 1 over a ln of absolute value. It is absolute value of the denominator, which is x plus a, then plus an arbitrary constant. So that is the final answer. So next example, how about if we're going to integrate a function of x squared minus 5x plus 3 over x cubed minus 4x squared plus 3x dx. First step, by factoring the denominator, it is equal to x squared minus 5x plus 3 dx. By factoring the denominator, we have a distinct linear factors of x times x minus 1 and x minus 3. So therefore, the equivalent fractions here is equal to, because we have 3 linear factors here, so also we have 3 constant. So we have a, b, and c. Then first we have a over x plus b over x minus 1, then plus c over x minus 3. Then it is dx. So therefore, by finding our a, b, and c constants, also we use our derived formulas. So we have from a, we have the function of numerator, which is x squared minus 5x plus 3 over the denominator of the other term, which is x minus 1 and x minus 3. X minus 1 and x minus 3. And we used to represent our x here because we have x plus 0, so we have x is equal to 0. And our b here also equal to the function of the numerator, which is x squared minus 5x plus 3 over the denominator of the other term, which is x and x minus 3. So we have here x times x minus 3. And we're gonna use to represent our x here because we're finding our b. So we have here in the denominator x minus 1. So we have here x is equal to 1. And by finding our c here, it is equal to also the numerator x squared minus 5x plus 3 over the denominator of the other term, which is x and x minus 1. So we have x times x minus 1. Then we're gonna use also to represent here because we have here the denominator of x minus 3. So our x here is equal to 3. So therefore, by substituting our x values, so to find our a, in the numerator we have here 0 raised to 2 is 0 minus 5 times 0 is 0. So we have here 3 over in the denominator we have. So we have here minus 1 times minus 3. So we have here plus 3. So our value b is equal to 1. So in b, in a constant of b, so we have 1, so x 1 raised to 2 is 1, minus 5 times 1 is 5, then plus 3, so we have minus 5 plus 3 is minus 2, then plus 1, we have minus 1 in the numerator, and in the denominator, in the inside we have here 1 minus 3, we have minus 2 times 1, so we have here minus 2, which is equal to 1/2. So in letter C, so we have here in the numerator, we have here x raised to 2, which is our x is equal to 3. So we have here 9 minus 5 times 3, which is 15. So 9 minus 15, then plus 3. So we have here 9 plus 3 is 12. So minus 15 is equal to negative 3. So over we have here 3. Inside we have 3 minus 1, which is 2, times 3, which is 6. So we have here negative 3 over 6, or equal to negative 1/2. So that is our value. This is our value of the constant a and a, b, and so by substituting our value in this equation, so we have here the integral of a, where our a is equal to 1, so we have here dx over x, then plus where our b is equal to 1/2, so we have here 1/2 integral of dx over x minus 1. Then our c here is equal to negative 1/2, so we have here minus 1/2 integral of dx over x minus 3. So we can easily integrate this function using the logarithm formula of integration. So we have here in the first term we have natural logarithm of absolute value of x, then plus 1/2 ln of absolute value of x minus 1, then minus 1/2 then ln of absolute value of x minus 3, then plus c. So that is the final answer. So last example, How about if we're going to integrate 3x squared plus 8x minus 12 dx over x cubed plus 7x squared plus 12x. So therefore, the first step we should do is to factor out the denominator. So therefore, it is equal to the integral of 3x squared plus 8 of x minus 12 dx over the factor of the denominator, which is x times x plus 3 x and x plus 4. So therefore, the equivalent fractions of these rational fractions is equal to a over x, then plus b over x plus 3, then plus c over x plus 4 and dx. So also, to find our value of constant a, b, and c, so we're going to use our derived formula. So for a, we have the numerator, which is 3x squared plus 8x minus 12 over the denominator of the other terms, which is x plus 3 and x plus 4. So over x plus 3 and x plus 4. So therefore, and because the denominator we have also is x, so we're gonna represent our x as 0. And by finding our b, we also have 3x squared plus 8x minus 12 over the denominator of the other term, which is x and x plus 4. So we have x times 6 plus 4. And because the denominator of b is x plus 3, so our x is equal to negative 3. So therefore, and then by finding our c, we also have 3x squared plus 8 of x minus 12 over the denominator of the other term, which is x and x plus 3, which is this. And also because we have the denominator of c, which is x plus 4, so therefore we're gonna represent our x, which is equal to negative 4. So therefore, by simplifying, in a, our value as x is equal to 0, so we have it's become 0, in the numerator it's become 0, and it's become 0, so we have in the numerator negative 12. Then the denominator, when it is 0, then when the x is 0, so we have 3 times 4, we have also 12, so it is equal to negative 1. By finding the value of our b in the numerator, where x is equal to negative 3, our numerator is equal to minus 9. So we have minus 9. And the denominator, where x is equal to negative 3, our denominator is equal to 3. So we have here minus 9 over minus 3, which is equal to positive 3. Then by finding our c here, then by finding the value of our c in the numerator, as our x is equal to negative 4, so our numerator is also equal to 4. Then in the denominator, where x is equal to negative 4, we have here negative 1 times negative 4, which is positive 4. So we have here 1. So also it is equal to 1. So therefore, this is our value of a, b, and c. So by substituting, so now we're going to integrate a over x, where a is equal to negative 1. So we put here in outside the integral sign, so we have here dx over x plus, then b, our b here is equal to 3. So therefore we put it outside the integral sign, so we have here dx over x plus 3. Then plus our c is equal to 1, so we're going to integral dx over x plus 4. So therefore we have here the integral of dx over x is simply ln of x, because we have negative here, so it is negative. Then the integral of dx over x plus 3 is simply ln of absolute value of x plus 3. And we have a multiplier of 3 here. Then the last term we have here the integral of dx over x plus 4. So we have here ln of absolute value of x plus 4. Then don't forget to add c. See, that is the final answer. And that is for this video. Don't forget to subscribe for more videos.